Greetings and welcome. In today's video, we're going to talk about the discriminant of the quadratic formula. And the discriminant is a portion of the formula that we can use to determine the nature of our roots, or the number of solutions we'll have, and kind of how our parabola would behave graphically and things like that. So looking at the quadratic formula, the thing that determines the number of solutions is going to be this radical portion right here, because that's kind of what is linked to the plus or minus, right? If this radical was 0, adding and subtracting 0 is going to give us only a single solution. I think we saw that in some of my previous videos. And if this radical happens to be of a positive number, then I'd add that positive number and subtract that positive number and get two distinct solutions there. And if it's negative, well, if the inside of the radical is negative, then I know that I'm adding and subtracting an imaginary number, and I would have no real solutions represented. So that's what we're going to talk about today, is that the discriminant is actually the radicand of the quadratic formula. Radicand is just the inside of a radical, all right? So the discriminant, d, is defined as being b squared minus 4ac, and a, b, and c are referring to the quadratic, right, in standard form, ax squared plus bx plus c, that is equal to 0, right? So a quadratic equal to 0, I can find a, b, and c. And if I plug them in the discriminant, it will tell me things about the problem prior to solving it. So let's actually do some of this classification. So if d is positive, what that tells me is there will be two real solutions. Now, if d is positive and is a perfect square, meaning like 9 or 100, right, perfect squares, then I'll have two real solutions that are rational solutions, meaning they will be represented as fractions, because the square root will simplify if it's a perfect square, right? And then I'll have some fraction represented by these situations, right? And then a third fact that it tells us is that the original problem is factorable. All right, so I guess I'll kind of turn this into a bit of a chart here. So the value of d, and then the facts that it tells us. All right. So let's consider the other case of when d is positive and d is not a perfect square. Well, I'll still have two real solutions, except this time, because the radical won't simplify, my answer will be irrational, all right? Meaning if I tried to find a decimal approximation of it, it would be infinitely long and non-repeating. And it also tells me, because it's not a perfect square, it tells me that the original problem is not factorable. So this would be a nice little test if I didn't want to, say, waste my time trying to factor a problem over and over again just to find out that it doesn't work. So let's consider this. What about when d is 0? So if the inside of this radical is 0, the square root of 0 is 0, adding and subtracting 0 is the same thing, and I'm just going to get a single answer, which is negative b over 2a. So I'll actually have one real solution. And I guess I could say that solution is negative b over 2a. And you might recall negative b over 2a back when we were graphing parabolas. That was the x-coordinate of the vertex. So this one real solution happens to be, it's the vertex of the parabola. Represented by the quadratic anyway. And that means, graphically speaking, it would hit my x-axis at a single point, so it's one of those ricochet sort of looking graphs where the parabola would come down and hit it at it, just kiss the graph at one little point, just a little peck on the cheek. And then if d is less than 0, that tells me there are two imaginary solutions. Right, because the square root of a negative number is going to give me some sort of I showing up. So this is my little chart, and all sorts of facts that I can determine based off of the value of the discriminant. All right, and if you think about the meaning of the word discriminate, right, in the English language, we think about kind of stereotyping or pre-categorizing usually people based off of some fact about them without even getting to know them. And that's kind of what the discriminant does, is it classifies or categorizes the types of answers I'll have based off of our kind of initial first glance at the problem. All right, so that'll at least help you remember it. So it's a good thing in this case. It's just a type of classification. So let's do an example. So my directions will typically say something like determine the nature of the roots. Basically saying, graphically speaking, how many x-intercepts does it have, or how many solutions does this equation have. Determining the nature also would be like, what kinds of solutions are they? For instance, are they rational, irrational, all sorts of things like that. So we're just going to be using the discriminant, my apologies, to figure this out. So let's do this for the problem. X squared minus 8x plus 16 equals 0. So looking at this problem, A is 1, B is negative 8, and C is 16. So I started exactly like I did when I was just doing the quadratic formula straight up. So the discriminant is equal to b squared, negative 8 all squared. If I don't have the parentheses, I will be wrong. And chances are I might even be wrong twice, which is even worse. Oh my goodness, terrible. Minus 4 times a times c. So negative 8 all squared is positive 64. 4 times 1 is 4 times 16 is 64. And I get d equals 0. So what does that tell us? It tells us we have one real solution. Right? And actually, in this case, I guess we could kind of pretend 0 is a perfect square, but the problem is factorable as well. I guess I could say that here. And it'll happen to be a pattern in that case. It'll actually be a perfect square trinomial whenever that happens. But that's okay. We'll just be fine with this. So one real solution occurs in that case. Let's do another one. What if I've got 5x squared plus 42 equals 0? So this time I'm missing a linear term, but we've got no problems with that. So A is 5, B is 0, and C is 42. So let's just plug it into the discriminant. So D is equal to B squared, so 0 squared minus 4 times A times C. Oh boy, let's see if I can do this math. Yikes. Well, I'm not worried about the 0 squared. I hope that's not what you're thinking. 0 squared is 0. This one's going to be negative. Negative times positive, positive, right? There's still one minus sign that doesn't have a friend to pair up with, and it's a negative result. 4 times 5 is 20. Let's see, 20 times 42. 2 times 42 would be 84. And then I think I'd tack a 0 on the end of that, right? So I end up with negative 840 as the value of the discriminant. And because it's negative, what does that tell me? I have two imaginary solutions. All right. So this isn't that bad, right? Let's get another one in here. What if I've got x squared minus 5x equals 50? So first of all, this is not in standard form, so I'd have to get it in said form so I can correctly determine the values of a, b, and c. Right? And let's see, so let's figure out what is a, b, and c. So a is 1, the little invisible coefficient of the quadratic term, b is negative 5, and c is negative 50. Here we go. So the discriminant is equal to b squared, so that's negative 5 squared, minus 4 times a is 1 times c is negative 50. So that is equal to negative 5 all squared. It's positive. Negative, positive, negative. I've got two negatives. They'll pair up, be positive. It looks like this will be a plus sign. And 4 times 50, I believe, is 200. So I get d is 225. Now, this is a positive number. So it tells me that I have two real solutions. Now, I don't know if you realize this, but 225 is the same as 15 squared, meaning that's a perfect square. So it tells me that my solutions are rational, and also because it's a perfect square, that tells me the original problem is actually factorable. Factorable. Right? So all sorts of information I can gather this just from this initial little litmus test. And not that tonight you would be having to solve these, but let's just for funsies, why not? Let's just solve this. Let's just solve this. See if it is in fact factorable. X squared minus 5x minus 50 equals 0. So let's see. Find the factors of 50, 1 and 50, 2 and 25. What am I finding these to do? I want them to subtract to be 5. Let's see, 3 doesn't work, 4 doesn't work, 5 and 10, oh, bing, 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 right there, and it would factor to be x with a 5, x with a 10 equals 0, and let's see, their signs are opposite, and the more influential number has to be negative, so minus plus, and then I'd be able to solve, right? X plus 5 equals 0, x minus 10 equals 0, and I'd get x equals negative 5, and x equals 10. So what do you know? The original problem was factorable. My answers were rational, right? These aren't crazy decimals that can't be, represented without rounding them. And these are two real solutions. So yeah, so that's the discriminant of the quadratic formula. Sometimes it's also called the radicand, merely because radicand is what you call the inside of a square root. So anyways, thanks for watching, and I'll see you guys next time.